Okay, so let's get some more practice in with our basic DTV type calculations. So let's take a little scenario here. Grab this. All right, so here you are in your boat going for a ride. And here, let's draw some, some water everywhere. Okay, so you're in the middle of a lake or an ocean or something, whatever. Right here, let's go something like that. Okay, this is the dock, and then there's like the shore over here, something like that. All right, all good. Okay, so here you are in your boat, and let's say you are traveling. You're traveling, I guess, north. I guess we'll say so. You're traveling north in your boat, and let's say you are going. Let's say you go 60 meters in your boat, straight forward, so to speak, and you're going at, let's go with 8.5 meters per second. All right, so you're going to go forward in your boat, and then you want to get to your dock, so you are going to turn perfectly this way to get to your dock. Okay, so you're going to go 60 meters, and we're going to do some compass directions. You're going to go 60 meters north, and you're traveling at 8.5 meters per second. And then you are going to, I guess, northwest, I guess is what that would be. So you're going to, for this part over here, you're going to go northwest. All right, and you're going to go northwest. And typically, you want to slow down when you're approaching a dock. So you're going to go northwest at 3.8 meters per second. Let's say for let's say 22 seconds. Okay. All right. So driving north, it's for 60 meters at 8.5, and then you're going to turn left, going perfectly northwest at 3.8 meters per second for 22 seconds to get to the dock. All right. So we're going to do, first of all, I'm not even going to give you the question. We're just going to start by finding what we can for the situation. There's two parts. I'm just going to find out the basics for each part, and then we'll worry about an actual question. So I'm going to start with the first part over here. I'm going to see for the first part, I've got my first distance, and I've got my first v. So I can use those to find the time for the first part. All right, so I'm going to find the time for the first part. So that'd be my distance divided by my v. So I've got that 60 meters, and I divide that by the 8.5. And we're looking at around 7.1 seconds. So that's how long the first part lasted for. Okay, so now I'll go to the second part. Like for the first part, I've got the D, I've got the V, I've got the T, I've got all that stuff. So let's go to the second part. For the second part, I've got the V and I've got the time. So I can find the distance for the second part. So I'll find my second distance. Okay, so all I have to do is multiply those two things together. So I've got the 3.8, and I'll times it by the 22, and my second distance is 83.6 meters. Okay, now even if I don't know what to do with these pieces, or if I need them, sometimes it's just great to find all the pieces for each part of a situation. All right, and then you can see if they're going to tie together later on. But let's just start by finding the bits and pieces. Okay. So now I've got the distance, the times, and the v's for each part. Okay, so let's look at an actual question here for you guys. All right, we're going to find two things. First one, I'm going to find out, pretty simple, okay, what is the average speed for the entire thing? Okay, so average speed for the entire thing, I will need to know my total distance and my total time. Okay, so luckily I've got all my bits and pieces, so that makes it really easy to put these things together. So my total distance, I'll take that 83.6 and I'll add that to my 60, and that gives me a total distance of 143.6 meters. And then for my total time, I've got the 22 seconds, and I found the 7.1, so put them together, so I got 29.1 seconds altogether. So then I just have to divide those two out. So I got the 143 divided by the 29.1, and we're looking around 4.9 meters per second is the average speed for the entire thing. Okay, all good. All right, so now let's find the average velocity for the entire thing. Now, of course, for average velocity, I don't want distance in time, I want displacement in time. So I have to break apart my vectors a little bit here and figure out my displacement. Now, really important, I need the displacement vector is what I need. So I'm going to break apart my d values. So I know when my little boat's cruising along here, it went, well, let's grab this. The first thing it did is it went 60 meters this way, and then it went 83.6 this way. So let's just take it one at a time. Let's start with my little vector going up like this. Went 60 meters this way, so I'm going to start with that. And this is where the little XY chart thing come in handy that we did with basic vectors. So if we do the XY chart for my displacement vectors, first thing it did is it went straight up. So the X component would be 0, and the Y component would be 60. All right, so that is from going from here to there. Now I want to go from here to there. So I got to break apart the second part of the situation. Now again, it's really important to be breaking apart the D's for this, not the V's. You want to break apart the D's. All right, so if I sort of look at that part over there, I know the second part is, I'll just sort of like redraw it over here a little bit, a mini version. I know the second part's going like this. I know it is 83.6 long, and since perfectly northwest, I know that's a 45-degree angle. So I just have to break apart that 83.6 into components. Now the nice thing is, since it is 45 degrees, I know the two components are going to be equal to each other, which works out really, really, really nicely. So if I break that part into X and Y components, my X component is going to be, well, they're both going to be like 59. And since it's going to the left, my X component would be negative. It is going up, so my Y component is going to be positive, so that's no big deal. All right, so now that I've broken those guys apart, just like we've done with our basic vectors, now we can add all the stuff together. Total X, negative 59. Total Y component, almost 120, not quite, 119. All right, so now that I've got my total X, I've got my total Y, I can make my new triangle. So I've got 59 going this way, and then I got 119 going up, and then I will go from beginning to end like this to get my overall resultant. So this is where your Pythagoras and your trig kick in again from when you did basic vector type stuff, of course. And we can find out this is about 133 meters. I'm going to solve for this angle right in there because that's the easiest one for me to solve for. So if I solve for that one, I get a little inside angle of around 64 degrees, something like that. Okay, so that's my displacement. So my displacement's 133, and then the 64 degrees in there. Okay, so if we're going to use that for average velocity, because average velocity is displacement over time. So I found my displacement, and that is the 133. So 133 meters, and the time is still the 29.1. That doesn't change at all. So I got the 133, and I'm going to divide that by 29.1, and we're going to get, again, we'll round off a little bit. It's like a 4.6 meters per second. Don't forget the angle. I need the angle. And since I started with compass, I should end with compass. So that's 64 degrees that we found. Well, that's 64 degrees. I don't have to take it from the positive X because I'm going to use compass directions. And that would be 64 degrees north of west. So that would be 64 degrees north of west. And that would be the average velocity. So average average speed is way easier. I mean, average velocity is often really, really easy as well. But as soon as you start doing like angle stuff, you got to break apart the D values, which can be a pain in the butt, but that's just the way it is. So it looks like a whole bunch of stuff on here. It looks really big complicated, but it's all about little tiny things. So what's the first thing we did? Just start by finding the individual things for the individual parts, solve each little section, no big deal. Then we did a little DTV over there. Okay, then we realized for average velocity we need displacement, so do our basic vector type stuff. Okay, and then we could apply to the average velocity calculations. Just one step at a time, and things generally piece together. It can be a little time consuming, especially when you're first starting to learn how to do this type of stuff, but generally it's relatively sequential and sort of the same type of thing over and over again. You just got to find the pieces, and one thing generally leads to the other. All right, okay. So let's try another type of question. Okay, similar type of thing with some angles and DTV stuff, and see what we can solve for. Okay, so let's try this. So I'm going to draw some ground here. Let's see, something like this. Oops, there we go. All right, got some ground. All right, excellent. Okay, and I'm going to draw. Here we go. Okay, like a mountain over here. Oh, let's make it taller than that. That's a little better. All right, let's go to the mountain. Actually, may as well make it like a volcano because why not? All right. Okay, so got like volcano mountain thing going on over there, and over here, we've got some little people here, and they are running. Okay, because. Whoops. They are running because there is a dragon that has come from the mountain, and the dragon is chasing the people. Okay, so the dragon's coming along, and let's say the dragon, I don't know, started over here or something at the bottom of the mountain. Okay, so the dragon's over here and is going to chase the people across the ground. Okay, so let's sort of lay out a couple things here, and then we'll expand on this a little bit. So let's say the dragon is coming this way, and let's say the dragon is moving at 14 meters per second for, let's just go with 20 seconds. So the dragon is moving at 14 meters per second for 20 seconds, chasing the people. And then over here, we have is, I guess, the hero. And he's got a nice big can of dragon repellent. And he can spray his dragon repellent. So he's got his anti-dragon spray. So the dragon is going to come along here, 14 meters per second for 20 seconds. Going to get scared off by the dragon's anti-dragon spray, and then go back to the top of his volcano mountain thingy back over there. Okay, so comes along 14 meters for 20 seconds. Then he's going to fly up this way, and let's say he's going at a 25 degree angle. He's going to head back the opposite way, and let's say he goes 280 meters, and he does that in well, not 280 meters. Let's go with 300. Yeah, 200, 300. Think about the 2 from the 20. All right, there you go. So 380 meters. 25 degrees, and let's say he does that 380 meters. Let's say he does that in, let's go with in 16 seconds. Okay, so we are going to find out what is the we're going to find the average velocity for the dragon. Okay, now let's forget about what we're looking for. Let's look at the information we have, and let's just piece together the different things. So there's two parts to this situation, and we can sort of find different things. So the first part there, I've got that 14 meters per second. I've got that 20 seconds. So I can find, I got my first V, I've got my first time, so I can find the first distance. So I'm just going to do that. D1 is equal to T1 V1. So I'm just going to put that together, and that's the 280 that had popped into my head before. So we got 280 meters for the first part going straight to the right. Then what he's going to do is he's going to turn back 25 degrees up and head back to the top of the mountain, and goes 380 at 16. So I got a 380 and I got the 16. So if I wanted to, I could find my second V and I could calculate that. Now, I already know that I'm not going to need that second V, but you could easily find that if you wanted to. There's nothing wrong with that, because who knows, I might incorporate later for something later on, who knows, but that wouldn't be too bad. So I know for average velocity, I need to know my displacement and my time. So for displacement, I would need to know my d's, and I've got my first d, and I've got my second d, and I got the angle, so that's all good to go. Time, I would need to know my times. Well, I got my first time, and I've got my second, so that's easy. I know this is the 36 seconds. That's easy. So I just need to figure out my displacement. And of course, since he's changing direction angle, I'm going to have to break apart my d values in order to find out my displacement vector. All right, so I'm going to break out a XY chart again, like before, XY chart, and break apart my d values. So first things first, my dragon starts over here, and first my dragon goes straight across 280 meters. So that's easy. So that's no big deal. So 280 meters straight to the right. So the x component would be 280 and the y component would be 0. That's easy. So then the next thing, of course, is the dragon comes across, and then it goes at 25 degrees back this way for 380 meters. So I just got to break apart this vector going up this way. So mostly to the left, a little bit up. So I'm going to break that one apart so for when the dragon's back up here. Okay. So let's do a little sketchy sketch here, and so we can sort of see a little bit. So the dragon is going back up this way, 380 meters. That is 25 degrees. So I just got to break this thing apart into the sideways and the vertical components. So when I break that thing apart, my x component is 344. And so he's going to the left, it's going to be negative. And then I will find the vertical component of that exact same triangle, and that's around 161. Okay, so like before, now we'll take these guys, we're going to put them together to get the overall displacement vector. That's easy, that's 161. And I got the 280, take away the 344, because he ends up further back than he started from. So negative 64 for that. So now that I have this, I can use that to make my new triangle. So again, if we laid this out for Mr. Dragon, he went this way, 280, and then he did the equivalent of 344 back and 161 up, or just went 380 diagonally this way. Okay, all right, so let's make the new triangle for my total displacement. So my net displacement is 64 to the left, and then 161 this way. All right, so I'm looking for my hypotenuse, something like that. So I'll use my Pythagoras, and I'll use my trig to figure out what that's going to be equal to. And this is around 173 meters. I'm going to solve for that angle right in there because easiest one for me to solve for. So I'll solve for that one. And I get an angle of 68 degrees in there. All right, so all good to go. All right, so I've got all my bits and pieces. I got everything I need. And even if I took this triangle, I could actually put it back in here. Like if I actually placed it here, I mean, it shows, the dragon started here, and the net displacement was right up here to the top of the volcano. Even if I just expanded that, maybe something like this. That was the displacement of the dragon overall. Okay, does it still fit? There we go. That's okay. Okay, so I've got my 173 as my displacement. I'm going to put that here. I've got my displacement. I've got my total time from before. So I've got that 173. I will divide that by the 36, and the average velocity for my dragon is 4.8 meters per second, which doesn't really seem like a lot because it isn't. But think about it. The dragon moved all that way to the right, and they moved all the way back left, and it went even further. Like it sort of undid a lot of what it did. So the total distance would have been pretty big. I mean, the total distance is almost 700 meters, but the displacement is only 173. And average velocity will always, always, always be equal to or often smaller than the average speed, especially if you change direction. Okay, all right, so the average velocity is 4.8 meters per second, and of course I need the angle, and for the angle, this is where I started from. I didn't start with compass, so I'm not going to end with compass, and I want the angle from the positive x-axis, so wrap around this way. So if that is 68, this should be 112 degrees right there, so I'm going to say 4.8 meters per second at 112 degrees. Okay, so that would be the average velocity for my dragon. And good thing he had his dragon repellent ready to go.